What happens when a simple feature video turns into a full-blown investigation of a potential brute force attack? Well, you got to stay tuned and find out. Okay, so I was originally going to bring you all a video talking about our super cool new filtering and how you can do multiple not clauses and then have nested ands and ors and get really crazy with it. But in doing so, I was attempting to generate data. And so I went very basic, wanted to look for failed user logins, right? And in doing so, I found that we were being brute forced. So figured that I would actually just walk through what I did to sanity check that and how it would apply to a production environment. So hopefully this is cool and helpful, but I thought it was pretty cool. So anyway, first things first, let's look at the query that we have here. We can see it's a lot of jumbled up stuff. One nice little addition, whether it's formatted by default or whether you ask Refine to format it for you, you can go ahead and you can hit this little button right here and it'll nice and pretty format it for you. So we can see very clearly this is just looking for failed user logins based on the event log over the past 7 days. And then we can see it's extracting relative information and then adds in this case statement for explaining what the substatus is so you can very clearly in plain text see what was the reason for a given failure. So I've already run this query, right? So let's go ahead and we'll check out the results. And I've run a couple others, which I'll walk through. But again, I was going through and I was like, okay, cool. So I ran that query across these 3 devices and I see 4,313 results in a week, which is kind of surprising because this is a vanilla empty box that I literally just use for generating data. So nothing on it, and there's no reason there should be that many failed logins, basically across all these machines. But first, let's try and hone in on which specific device it is, this is the exact process I went through. And so as you can see, our new revamped filtering, which I'll talk more about in a minute, or maybe do a whole separate video on, since this one's more about triage. But first, let's look for the agent name equals that specific agent name. And then we can see that the total number of rows went from 4313 to also 4313. So if we do a not filter, just a sanity check real quick, we'll see we get 0 results. So we can very safely assume, okay, it's only on this one device for the current moment in time. So before I actually continue to investigate this further, my very first thought process is, okay, well, I need to take action. Well, I need to go live on the machine, disable that device, whatever. So how do I go about doing that? Well, as you may have guessed, I'm going to check the inverse. I'm going to check for successful logins on that specific device now that we've honed down the 3 devices to that specific one device and see if there are any successful logins that may raise some eyebrows over the past week, so in the same period of time. Very simple, very straightforward. We see we have 57 results, and I can save you the trouble of clicking to the next page. All of them are system, NT authority, login type of 5, which is a service login. So realistically, we'd be looking for something like a what is it, 10, 3, and 3 is like network, 10 could be, I think it's SMB, and then there's 2, which is interactive. So we're looking for something like that. A 5 service login is not necessarily suspicious at all, especially as this is an EC2 instance. This is highly likely just the SSM agent operating so that we can remote into that machine, what have you, right? So okay, I can take a deep breath, which is exactly what happened. I was like, holy crap. And then I was like, okay, you know what? Either way, there's nothing on this machine, but I'm not seeing any evidence of them getting on the device. Now, granted, that's exactly where OS Query excels, is things on the device. So at this point, the amount of information that we'll be able to get outside of this is going to be relatively limited. But that's kind of the point, right? The point is that it helps resolve problems by adding context, right? So it's not that it's going to do everything, it's that it's going to add additional context where helpful. So I did a little basic sanity check. I took a bunch of the IP addresses within the brute force and then checked them against process open sockets, just in a list, some of the most prevalent ones that I saw. And we can see no processes are actively connecting to those. So that's all well and good, fully expected, but might as well have that sanity check. The next thing that I like to do, as I kind of mentioned, so when I'm in here, I actually went through and did a bunch of filtering. I may do it on the fly. I'm just worried that I'll fat finger some stuff. But first thing, I always filter right here on the timestamp. So what I actually did is I went ahead and I downloaded the CSV of the results, right? Just because I can add more logic to massage after the fact. So one of the common things I like to look at right here is I added a little field of time delta in minutes. So effectively it looks at this event and then subtracts this event's time from it and then multiplies it by effectively the amount to get minutes to see if there's a recurring pattern. And you can see right away that there is. This is basically every single hour and 2 minutes on the dot. This specific IP address, the 172, is reaching out trying to connect to administrator admin. You can see the pattern very clearly. What I also thought was interesting is if you scroll down a little bit, we can see from this 210 IP address, we're constantly getting what appears to be, I would guess, scripted, because you can type admin and administrator within a minute, like for sure. That's definitely within the reasonable threshold. But the consistency with which it's happening, and then a bunch of different accounts, all from the same IP address, all within roughly the same time frame, give or take maybe 15 seconds, since this is in minutes, right? So it seems to me that this is a script that is going ahead and trying to brute force a bunch of different ones with, maybe some level of like, hey, prioritize admin, whatever, with a random number generator between, 1 and 15, because we can see that pattern super clearly right here, right? So the only outlier of the pattern is actually the ones that are not from that IP address, which we're seeing right here, the 172, and then that's why this one seems off. But in general, they all roughly follow that same logic. So I can look at this and say, okay, it seems really weird unless they're setting a timer that's like, hey, you know what, every exactly 1 hour and 2 minutes, let's go ahead and actually try administrator and then switch off to admin manually. That seems unlikely. And then even more unlikely seems random, login name generators with each of these, values within a given minute. So I can now assume that, okay, it's probably scripted. It's probably just trying to go out there and get anything it can. It identified this as an available device on the network, or publicly, that it can access via the public IP address, and then it's trying to just brute force it and see what it can get. So what I actually also did is I took those IP addresses and then referenced them in this MaxMind, to go ahead and get some more information on the specific IP addresses that I saw come up the most commonly. And as we can see, they're all over the place. So Zurich, Hong Kong, Buenos Aires, Ukraine, Indonesia, Cairo, Frankfurt, and then US based, because it's Azure within this 172. So now we have a little bit better information. Realistically, what this tells us is that it's probably just a botnet scripting and then trying to brute force anything it can find. So, nothing that seems crazy targeted. The only interesting piece from the targeting side, is that if we go back to the query for the failed logins, and then we start adding some of this logic, right? So I can add a condition just to show the filtering. We already know that they're only on this device, but just for the sake of it, I'll add that filter. I'll sort this accordingly. And then what I can do is add a subgroup. So as you can see within the subgroup, it's basically, are each of these conditions going to be and operators or operators, and then is the entire group going to be not, or you could do it for each element, as you're seeing here. So it is very simple. If you actually draw it out, which we see in the URL when you apply this, it's very straightforward, but I'll actually show you kind of some of the workflow I was going through. So specifically, I know that 6A, I added the substatus code. It makes it very easy to determine what we're looking for. But so 6A is wrong password, which means that that account does exist on the device, right? So we know that administrator exists by default on Windows devices. 6.4 is no such user, right? So then what we see here is admin. There isn't an admin, there's administrator. So what we can do is we can actually go ahead and go to substatus raw and hit contains, and then say 6.4. So let's see all the times where they were actually trying fake usernames, not one of the built-in real usernames. Because again, this machine's never been used, so there's no real usernames other than just installing the agent. And what we can see is a pretty random smattering. If we break this down even further, we can go through and we can see if any stand out. And there was one that stood out in particular, and so I'm wondering if it's coming from some of these videos. But if we look at it, we go through, nothing crazy, just seems like random name generators. We'll keep going. And then there is still roughly test random name generators. I could filter this based on the IP address if I wanted to, or remove IP addresses, which is what I believe I did before. But even just for the sake of it, let's go ahead and we'll add a condition and we'll say, let's just remove target username of admin, not admin, and then hit apply. And so we can see that reduces it to 115 rows. Much easier to view that data, right? That's going to be 3 total pages. And again, just user, open support, systems, et cetera, just a bunch of generic things here. User, there's a couple guests that I saw, but that would show up. And then I saw one that was Nick, which I thought was odd. There is an Adam, right? Which, kind of maybe that's admin, but it is odd that they picked one specifically for Nick. So I'm wondering if there is some level of research and maybe a little bit more targeted because they're using my name. But either way, I haven't seen anything resulting from it, but it is something to note down and keep an eye on in the future. And then what we can also do, again, of course, we could filter out these IP addresses. But one thing I like to do is actually flip this target domain here, and we see there's only one associated for abuse.xmco.com. Don't know what that is. Did some basic research. It could be associated with some sort of crawling for threat intel, but at the same time, why is it attempting to log in? It's probably not great information. And then we can see the same stuff with like workspace name and the frequency of changing the IP addresses. So, for all intents and purposes, what we've effectively gone to and solved, which I know this has been a longer video than I originally intended, but hopefully it was a little bit cool, is effectively we saw potential brute force, right? Then we've identified and validated that none of it's actively connecting via the query that we had over here. If we look at our query results page, there are no active connections. Again, it's point in time, it's expected there isn't any active connections across our devices in our fleet. But the more important one is that we checked and we didn't see any successful logins emanating from that device within the time period. I'd probably want to expand the scope out just to see, but if that's the case, we'd probably get less random brute forces and randomized naming conventions and more targeted consistence, and then we'd be looking into persistence mechanisms on that system. So with that said, we now say, okay, it's probably not in our environment, so we're probably good, probably no immediate worry. And then we've gone ahead and we've tried to ascertain kind of the nature of, is this a broad botnet? Is this targeted? That one's a little bit shady because we can tell this is definitely scripted just with the consistency of the time intervals via the CSV export, where we now can manipulate the data even further. But we can see that it seems like it's scripted given the consistency of this field here and the deltas of time between each one of these requests. We've gone ahead, we've checked if there's a specific one emanating location. We can see it varies, so it is potentially botnet, with the one super interesting caveat that one of the login attempts had the name of Nick. That's my name. So that is a little bit odd, and we may want to keep eyes on that device. But honestly, this is kind of the overarching point of where AI query fits into your workflow, is that it's not going to give you all the answers, but it is a very good way to provide additional context because now I have this list of IP addresses, right? I have this consistency of potential domain names, potential workstation names, IP addresses, things that they're probing for. Now I can use that to go back and harden my EC2 instance further and also provide that information to the network team to then actually now be on the lookout for some sort of consistent behavior of this nature. And what's also interesting is that we know that in our other EC2 instances, we're actually not seeing this brute force. It's just this one specific one. So maybe we want to investigate why. So that was a little bit longer than I intended. I thought it was cool. I wanted to kind of walk through that. So hopefully you stuck around. And yeah, hopefully that was helpful. And also our filtering is super sweet now. But anyway, if you have any other, I guess, use cases, this wasn't a use case that was given. This just randomly happened. But if you have any other suggestions for stuff for me to go through, or if there's something that I may have missed in this investigation that you're like, whoa, dude, you did not check XYZ or your assumption of ABC was incorrect, please let me know. I am here to learn every friggin' day. So yeah, please let me know. And otherwise, please check out our videos on YouTube and LinkedIn. And until next time, see you, everybody.